What I have in front of us here is the reef reinforcement cage of a pile. This is a square object. It will end up being 28 inches by 28 inches by 19.5 feet long. This is a rebar cage that then goes into a set of forms in which then you pour concrete in and you make a pile. What's different about this object as opposed to a regular pile that we drive into the ground is that this pile is not pre-stressed. This particular object, as you notice here, has mild steel everywhere. And the reason why it isn't pre-stressed, where you, for instance, have pre-stressing strands, stretch them out, and then concrete it later, then cut the strands and put the whole object in compression is that this object will never experience this driving process, that you have tension stresses in the driving process. This object will be jetted into the ground. And if you look down at the bottom here, you have the exit ports. So here's where the water will be coming out, and they'll be creating the void, the hole, to install the pile. Why do I want to do this as opposed to drive a pile is there's no vibrations associated with this compared to having a pre-stressed concrete pile. I have to put in a set of leads and drive it with a hammer, and I create a lot of vibration which causes problems or distress with nearby structures. With this approach, I can, for instance, install the pile with the water with no vibrations, and then in order to get the capacity I want of this object, I come up along the side of here, and now you see these external grouting pipes. And these objects, these grout pipes, go to the top, and there are two sets of these. There's a top set and a bottom set. The purpose of the grout pipes there is to grout around the object after it's installed. To jet the pile, I now grout the system from the bottom. If I've done it correctly, I'll form a bulb down here. And this bulb will push up on the bottom of the pile and push down. That pressure times the area is the resistance, this pile, the resistance, the skin friction I can mobilize. So the capacity of this pile would be then twice whatever the grout pressure times the area is on the bottom that this pile could support. And that would be pushing up and pushing down. One would be tip, one would be skin friction, okay? So what does that do? Why do I want to grout the system? What benefit of that, grouting the tip of this system, is it's a proof test. So the proof test concept here is, okay, I live in coastal areas. In Florida, I look at all the Florida's got a lot of coastal areas. I have a lot of variability of the soil conditions here. And so if I look at the capacities of one object, this object, if I look at it in Tampa, I look at it in Orlando, or I look at it in Jacksonville, I'll see different capacities of piles in different soils. And so I would like to validate the capacity that I have in the ground. Now to validate this, I can also monitor the object. And how do I monitor them is through strain gauges. And you can see these little PVC pipes running along the side. This is a strain gauge right here. Notice there's one over here and there's one over there. What this does, it measures the compression of the pile. It tells me how much is being compressed. If I know that times the property of the material, I can tell you what the stress is and what the force is at the bottom of the object. This process allows us to test every object in every soil conditions it sees and gives an assessment of its capacity directly.